Today we're talking about calculating perimeter and area. But unlike perimeter and area that you've done in the past, in today's video we're not always going to be given every piece of information we need, and we need to be able to find them. You already know some basics about perimeter and area, like the fact that the perimeter is the sum of all the sides. In other words, the distance it would take for you to walk around the outside border of an object. So if this stick figure is going to walk all the way around the outside of this rectangle, he's going to go 8 feet forward, then another 4 feet, 8 more feet, and then add an additional 4 feet onto the end. When I add all those distances together, I can see that he's going to walk a total of 24 feet. And that's my perimeter. Again, perimeter is the sum of all the sides, regardless of what type of shape you have. Area is very different from perimeter, however. Where perimeter talks about the outside of a shape, area is the inside of a shape. So this rectangle is 8 feet in one direction, so I'm going to split it up into all the individual feet lengths, or foot lengths, I guess I should say. And it's 4 feet going the other direction. When I actually split my rectangle up that way, I can see that it splits into many different squares, and every single one of those squares is a 1 foot by 1 foot square. And that's what's called a square foot. The area of an object is counting how many of those little square feet can fit inside the figure. And whether it's a circle or a triangle or a trapezoid or any type of shape, it's the same thing. We're trying to count how many of those little 1 by 1 squares can fit inside that particular shape. In this case, I have 4 rows, each containing 8 squares. 4 times 8 gives me 32 square feet, and that is our area. If we take what we call the base times the height, right, the length times the width, or whatever you want to call that, and multiply it together, that's going to give us our area. A triangle, as a side note, will always take up exactly half of some given rectangle or square or some other 4-sided shape. So always remember that a triangle is 1/2 of a rectangle, and that will help you when you try to remember your area formulas. The area formula for a rectangle is simply base times height, just like the rectangle we saw a minute ago. One thing to recall before we get too deep into this topic is that the base and the height of any given shape must be perpendicular to one another. That's the only requirement. The base does not always have to be horizontal, and the height does not always have to be vertical. Just keep that in mind. They just have to be perpendicular to one another. So when I'm looking at the base and the height of a triangle, again, sometimes the height is not one of the 3 sides given. It has to be absolutely perpendicular to the base. And of course it has to go through that 3rd point that's not on the base, but that's another story. So remember how we said a triangle takes up half the area of a rectangle? So to find the area of a triangle, we multiply the base times the height, but then we have to divide that in half, or divide by 2. Same with an object like a parallelogram. If the height is not one of my given sides, sometimes I have to actually find that length. What's important to remember today, though, is that the height and the base always are 2 sides that are perpendicular. So let's say we're given a triangle ABC with vertices at -3, 1, 1, 3, and 2, -4, and we have to find the perimeter of that triangle. Now we definitely don't have a graph However, if I were to graph that triangle, I know I don't have this on a grid, but it would look something like this. Just so that I can see the 3 different side lengths and make sure I don't have anything that's horizontal or vertical that's really easy to find the length of. Since I need to find perimeter, I need to know the length of every single side, and since nothing here is horizontal or vertical, I'm going to have to use distance formula to get that job done. Plugging these vertices 2 at a time, right? A and B, then B and C, then A and C, into distance formula, I find my 3 triangle side lengths. If I need to find the perimeter then, I simply add those side lengths together and I get the total perimeter or distance around the outside of that triangle. The reason that I left these as square roots until the very end is because chances are you're going to be figuring this out on a calculator. And if you keep rounding and then rounding again and rounding again, you're going to get a pretty inaccurate perimeter or area. So if you're given something like square root of 20 and square root of 50, I encourage you to leave it in that form until the very, very end and then round your final answer to however many decimal places are in the instructions. We're given a rectangle ABCD that has the following 4 vertices, and we're asked to calculate the area of that rectangle. Again, looking at the shape of that rectangle on a graph, and again, I didn't worry about putting this on a grid. I just wanted to see if I had anything that was vertical or horizontal that I could just count the side length quickly. Since that didn't happen, I've got to do something else. Some things to remember about the properties of a rectangle. Remember the base and height are perpendicular. And we said just a second ago that there's no requirement as to which side is the base and which side is the height. So really we can pick any 2 sides that are perpendicular to one another and simply call those 2 sides base and height. So I'm going to pick AB and BC because those are consecutive sides. And if I find their length using distance formula, I can see that they're definitely not the same length, right? But what else do I need to know? Do I need to know anything else, given that it's a rectangle? Can I call those 2 sides base and height and go ahead and find the area? You bet we can. So to find the area, we simply multiply those 2 values together, one that we call base and one that we call height. I get the square root of 400 when I multiply those side lengths together, which gives me 20 square units. And because this is area, don't forget to put square units instead of just units. The same exact procedure can work for the 2 perpendicular sides on a right triangle, by the way, because I'm pretty sure you'll see that in your assignment later. Alright, I'm going to keep this short today. Don't forget that you can go back and rewind and watch examples again if needs be. Otherwise, I'm going to wish you a fantastic day, and I'll see you next time.